All right, this is question 19. It says, consider the quadratic function here. The vertex, remember the vertex formula? We have negative b over 2a is our x coordinate. And then to get the y coordinate, we're gonna just plug that value back into the function to get the y coordinate. So if I want to find the x coordinate, I'm just going to start by saying x equals negative b. If b is already negative, it's going to become positive. So this is positive 19 over 2 times a, 2 times 3, which is 6. So the x coordinate of my vertex is 19 divided by 6, or 3.166 repeating. So let's do 3.1666. And then if I want to find the y coordinate, I have to plug that value back into the equation. So I'm going to do 3 times, let's just do 3.16. We'll do 3.17. That should be good enough. 3.17 squared minus 19 times 3.17 minus 40. So we get negative 70.083. So I'm not sure how they went around it, but that seems good enough to me. We can do like that, 3.1667. That should be better, not 6. Okay, that's the first one. This is just your vertex formula. You're going to use this for the next couple problems, actually. So this talks about sunglasses, and it says we have a profit function here. How many pairs of sunglasses? So basically, what is Q to maximize profit? So we're maximizing something. So if I were to graph this, since it has a negative A, it's going to look like this. So I'm looking for the maximum, the top, the vertex. So we're using the vertex formula again. So the instead of x, we're going to use q. The q coordinate is going to be negative b, negative 5, over 2a. So that's negative 0.06. I just did 2 times that. So plugging that in, I get negative 5 divided by negative 0.06. And I get 83.33 repeating. So it says round to 3 decimal places, 83.333. And then it says, what are the actual maximum profits? Again, you're just going to plug this value in for Q. So we have negative 0.03 times 83.333 squared plus 5 times 83.333 minus 28. We get 180.333. That's it. You're going to do the same thing here. The maximum height of the ball, that's just the vertex formula. But the maximum height, you're going to find the t coordinate, and then you have to plug that back in to get what the maximum height is. So basically, you're doing the same thing we did here for numbers 21. Okay. How many seconds does it take till the ball hits the ground? We're going to set this thing equal to 0. I want to know t when h equals 0. So I have negative 16t squared plus 88t plus 48 equals 0. You're going to dive right into the quadratic formula. T equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And then you'll get a positive answer and a negative answer. This is just going to be the positive answer because the negative answer doesn't make any sense. So whatever you get that's positive, that's going to go right here. Okay, and the last one, oh, I don't know if I copied that yet. This last one here. Okay, so we have this. You can ignore all this data. You don't need any of this except for the equation, the function. So then it says, is the function a good one off the data? Yeah, it seems to go through the data points pretty well. So we're just going to hit yes. It says, estimate the fuel consumption in 2010. Well, this is years since 1990. So I want to know the consumption in 2010. You're going to just put in how many years since 1990 is 2010. Well, that's 20 years. Just going to plug 20 in for T and tell me what you get out. Okay, and then it says use the model to predict in which year the fuel consumption will peak. That's a maximum. We're going to use the Vertex formula again, negative b over 2a. Whatever you get for t, that's your answer. Just remember, t is in terms of years since 1990. So let's just say t was 15. Don't put 15 here. You're going to put 15 plus 1990, which would be 2005.